Hey guys, today we're going to be looking at some trig identities. So let's get started right now. So the first one, which is called the Pythagorean identity, is probably the most important one to know. Sorry, I'll get that straight. So let me write it out right here. Okay, and remember this means theta. So it just represents an angle. And you can also write it as x, that's all, okay? And then there are two other equations that stem from here. And all you have to do to get them is divide it by either one of these. And what I mean by that is, let me show you. So let's say I divide this by sine square theta, and I divide this by sine square theta, right? And I divide this by sine square theta, okay? So I'm dividing everything by this term. So what will I get? Let's write that down right here. So it'll be 1. This will be cotangent, right? And then 1 over sine is cosecant theta. Okay? So just in case you guys forgot, I can write, so just in case you forgot, let me write the basic reciprocal identities off to the side over here, okay? So sine is equal to 1 over cosecant, okay? Cosine to 1 over secant. Remember, there should be like an x right after each of the identities, but I don't have enough space, so I'll just keep it like here. And then tan x is 1 over cotangent, okay? And then cosecant is 1 over sine, and then these two are switched, and then these two are switched, okay? And remember that tan is sine over cosine, okay? And then for cotangent, it's this but reversed, so it'll equal cosine over sine, okay? I'm just gonna erase this, but this is just so you guys know now, okay? So we have our two Pythagorean identities, and then to get the last one, you've probably guessed by now, you just have to divide this whole equation by cosine squared theta instead, okay? So what are we gonna get? 1 equals, the 1 goes after. So you do sine over cosine, which we just discussed, is tan squared theta. Then cosine over cosine is 1. Then 1 over cosine equals secant. Okay, so those are the, I spelled that wrong. Pythagorean identities, okay? Those are probably the most important ones. And now let's go down a bit. Or let me zoom out, okay? Okay. Now let's talk about our even and odd identities, okay? So I'm just going to be focusing on sine, cosine, and tan. So when the function is negated, okay, as we can see here, when the input is negated, the whole entire function, or the y value, is inverted or negated too, okay? And the same pattern follows tan, okay? But look at this. for cosine, when you negate the input, you still get a positive value, okay? And this trend is this trend occurs when the function is an even function. So what I'm highlighting green, that means it's even. Then green means odd, okay? So when it's odd, the function will become negative when the input is negative. But here, the function is still positive, okay? So now we have that, okay? And let me remind you of the graph, actually, for sine, tan, and cosine, just so you know, you can see how the odd and even actually relates in this case. So the sine graph looks something like this, right? Oh, sorry, not very good. Let me draw that again. It goes through the origin, and it's like this, okay? Something like that, whatever. But that means it's point symmetry, okay? You can see that's not reflected over the y-axis. And the same thing happens for the tan graph. It looks like this, right? Point symmetry. But for the cosine graph, it's like this, okay? See? It's symmetric along the y-axis, meaning it's even, okay? So this is even, this is odd, odd. So point symmetry is also known as rotational symmetry. So don't forget that, okay? And this is called axis symmetry. Okay, so that's another important thing to know. Let me get some more space here. Okay. Now we have our sum and difference identities, okay? So let's go over those. So this was one section. This was another section. Now let's write this out here. So sine of A plus B equals okay, so that's our sum identity, okay? So in this case, let's see how we would apply this to our real problem, okay? So you might be a little bit confused, but it's very simple. So let's say the problem says that it's, I don't know, sine of 90, okay? Another way to write this is sine of 45 plus 45, right? And looking at this formula, we can go back to here. That'll look like this. Sine of 45 cosine 45 plus cosine 45 sine 45, okay? Because this is A, okay, and this is B. So even though if it's sine of, let's say, 60 plus 30, I could also do that too. This would be, or sorry, let me use this color. This would be 60, and this would also be 60. And this would be 30 and 30, okay? So the green is what the A value is, and the B is what the B value is, okay? And if it's a difference identity, this thing will be negative and this sign will be negative. That's all, okay? And the process is very similar for when, right here, when this is cosine, it's essentially the same thing. So you would switch out, you know, the order of the sine and cosine, okay? And now we can look at the tan identity, okay? Which is a bit more confusing, or not confusing, but it's a little different. So let's write that down here. Okay? essentially the same concept. Let me just write it down. So it'll be tan of A minus tan of B, okay? All over 1 minus, oh sorry, here is the plus. 1 minus tan A tan B, okay? And when this is negative, okay? This becomes negative and this becomes positive. So basically the signs just switch, okay? So this is your formula, and remember, this is A, this is B, then this is A goes here, then B goes here, and here, okay? So those are the sum and difference identities. And now we're gonna look at half angles. I'm gonna move up here for more space, okay? Okay. So let's write this down. Sine of theta over 2. Oh yeah, I just want to clarify. When I wrote A and B, like over here, here and here, those are angles, okay? Like angle A, angle B. Like I wrote it here, but just in case, yeah? Okay, let's go back. So this would equal plus or minus 1/2 1 minus cosine of x, okay? So this formula isn't complicated except for this thing right here. Because when you're writing your answer, you cannot leave it like this. You have to either put a positive sign or a negative sign. So how to know this is basically thinking about the graph, okay? So let's say our theta here, so not the half angle, but the full angle, right? Let's say it was right here, okay? So all of this. So an angle from this quadrant would be like what? Could be an angle, let's say 300, okay? So its half angle would equal 150. And where is 150? It's right here, okay? And we know that sine, like for this example, sine is negative in this quadrant and this quadrant. So the half angle is 150, which is in this quadrant. So our half angle will be negative, okay? But let's say this was a cosine formula, okay? Because the cosine formula is the same, except this is a plus sign, okay? So when this is cosine, okay, it becomes positive. So it'll look like this. And let's say this is the angle. So even though cosine is positive here, it's negative here. So for this half angle, the half angle would be negative, yet the full angle would be positive, okay? So you have to be aware of those things. And yeah. The tan formula is very similar, except there are more variations, or more ways of writing it out, but it's essentially the same thing, so I'll just write it out here, okay? So over 2 equals plus or minus 1 minus cosine x over 1 plus cosine x. And that's also equal to sine of x over 1 plus cosine x equals to 1 minus cosine x. So all of these, cosine x. All of these are different ways to write the half angle of tan of x, okay? And now I want to go over double angles. And this will be our last important identity to go over today. So let's look at double angles, okay? Sine, let me get a better color. I'm going to zoom it in since this is our last part anyway. So this one is pretty self-explanatory. I don't really have to go over it. So this is an x. The x goes here. You just have to find the sine and cosine of it, and that'll equal your double angle. Then if it's cosine 2 over x, there are many ways to write it. And usually use all these identities to simplify, okay, trig functions. And the trick to simplifying fast is to recognize which cosine double angle to use. So I'll explain after I write these out. Okay, so what I mean is that when simplifying, you try to find factors to cancel out, right? Because that makes the number smaller, or that makes the function smaller, okay? That's what simplifying is all about. And when you're doing that, you're trying to see what you can cancel out. So if the numerator has a double angle, let's say like a cosine double angle, and in the denominator has, I don't know, like a cosine x squared or something, or something like that. Or if the thing with the cosine double angle, or like if the cosine double angle is in the denominator and there's also a positive one there by any chance, then you would probably want to use this, right? Because the 1 in this negative 1 would cancel out if there was a 1 here, okay? So things like that you should be aware of. And now we'll go to our last double angle. Oh, different color this time, right? And that's 10. Okay, so that's our last identity, and this one is pretty self-explanatory, right? We have everything right here. So yeah, this was it. This was an overview of all the major trig identities, okay? Oh, sorry, that's not what I wanted. And although these formulas are usually given to you on a test, it's good to memorize them and have them, at the tip of your brain, if you want to say. So it's easier to apply and you'll finish the problem faster.